So another thing I would like to highlight is this one, 1 over n. Okay, let me delete this one first before you confuse with this. I just delete this marker. Okay, actually this 1 over n, okay, actually this one should be not 1 over n, so that's why you can see over here there's no 1 over n. Okay, what I've discussed before, there's no 1 over n, but this one I forget to delete because this one I get from another source. Actually at this point they are not using SSE as the cost function. Okay, if you remember, our cost function should be, okay, summation of your fxi, okay, which is this one. This is the cost, this is what we call as a SSE concept. Okay, of course there's no square anymore because square have been cancelled with 1 over 2, okay, when you derive this equation. Okay, but another method or another cost function that I highlight before that we don't discuss is what we call as a mean square error. Okay, what is meaning by mean square error? Okay, in mean square error, what in order to you to find or to compute the mean square error, the expression is look like this. Okay, again this is okay, this is your SSE. Okay, this is your, if you set your cost function as SSE, okay, this is how it should look like. And this is what we have discussed before. We are using the SSE. But another cost function that common in this linear regression is what we call as the MSE, which is mean square error. Okay, SSE is the sum of square error. Mean square error is MSE is a mean square error. So what is the meaning of mean square error? Is that you are take the total errors there previously. You are not taking that total error as a value of cost function. You divide with 1 over n to get the minimum, to get the mean or the average error happen at that case. Okay, so that's why if you see over here, if you want to change your cost function into MSE, from SSE to MSE, then it's look like this. You will have 1 over 2, actually 1 over 2 minus, 1 over 2 times 1 over n, meaning the total errors you must divide with 1000. Okay, if you talk about your sample, if the sample size is 1000. Okay, so that's why so that is the one that only change in the equation, meaning that if you use that thing, means that now the 2 there is not just 2. If you talk about the MSE, then this one all become 1 over 2n, and then this one 1 over 2n, and here at lastly we will have something here at the end. There's a 1 over n at the outside, okay, at this derivation. And that's why in this slide, okay, same so goes to this slide. If you are using MSE, it should be 1 over n, and at the end this is how it has been produced. Okay, so this one is not SSE, this one is if you are using MSE. Okay, so I hope that you clear about that one, but and also clear about this discussion about the batch gradient descent, stochastic gradient descent, and mini batch gradient descent, because later when we discuss about the artificial neural network, most of the time we are still using this mode, which is a stochastic gradient descent, the one that you learn here. Okay, which is update one times one sample and update your parameter. Update, take one sample, update your parameter. But when you are doing the, later when we talk about the deep learning, and then we learn about the convolutional neural network, when you want to do some project, you will see that the most recent approach in doesn't matter is it Python or MATLAB, they are using this concept which is called a mini batch gradient descent. That's why when you want to do some training process, you need to set the mini batch size. Okay. Okay, then the last slide, then you can read that is just comparison between the gradient descent and least square method. Okay, this one is a least square method that you learned before. Okay, so that is the disadvantage and so on. So non-iterative, again there's no iterative process, and then this one is slow. If the actually this one is incorrect, I think this one should be N, it's not D. Okay, so if the N is too big, that is the big issue happened that makes most of people's prefer gradient descent in order to proceed the linear regression. Okay, because in order to solve or finding the proceed the hyperparameter tuning, they are prefer to use a gradient descent when okay, this is the reason, this is the big reason, because when they are dealing with practicals example, of course there's a lot of data, and then at the end the least square method is not in practical to be done. That's why they are prefer the gradient descent.